All right. So beta particles are just a tad bit more complicated and what seemed like a little bit more confusing than alpha particles. But like I said, my goal is to break this down for you so that you can understand it. The other thing is I found a really great website and video clip that I'm going to attach as well so that maybe you can see this visually. And like I said, I'm going to attach my notes also. Okay. But beta particles are also transmutation. In other words, the atom is changing into a different type of atom. Okay? So what we're happening here is you have a neutron, okay? Now that neutron is going to change to a proton. I know that sounds really strange. And that proton, or excuse me, a proton and electron, excuse me here. But the atom is going to kick out the electron. So ultimately, okay, what you have here is your atomic number is going up. Okay? Why is your atomic number going up? Because a neutron is becoming a proton. When you change the proton, you change what the atom actually is. Okay? Now, the reason I'm kind of emphasizing the proton and the atomic number, because now that the atom has changed and you have a different number of protons, a lot of people think, oh my goodness, that means the atomic mass changes. Wrong. The atomic mass stays the same. Why? Because neutrons and protons make up the nucleus. Okay? So even if a neutron changes to a proton, it's still all in the nucleus together. It's still going to have the same mass. So the atomic mass stays the same. The atomic number is the only thing that goes up. Now, what's really important here is it's kicking out an electron. Okay? When that releases that electron, okay, this is what your notes, let me kind of pull back over here. Your notes were showing you. This is how we kind of demonstrate that. Okay? 0. The reason we have that 0 there, guys, is because that's supposed to represent your mass. Electrons really don't even have a mass. They don't really, that's why we only say the atomic mass is made up of protons and neutrons. So it's got a 0 there. The negative just tells us electrons have a negative charge. Okay? And now put that little note over here. Remember, electrons have no mass and a charge of -1. Okay? So simplifying this, alpha and beta, okay, cause transmutations. In other words, the atom is changing from one thing to another. Alpha releases a helium particle and can be stopped by paper. It's really large, but can only travel a few inches, okay? Beta particles are only emitting an electron. How do I get the electron? A neutron is going to become a proton and an electron, and it's going to spit that electron out, okay? Now, because it's going to have a little bit more energy, beta particles actually travel further, okay? So they can travel further than alpha particles, and it takes more than just a sheet of paper to stop them. Most of these can be stopped, stopped with aluminum foil, okay? Even plastic can stop beta particles. What's really interesting is we think, oh, radiation is such a negative thing, but you guys saw the video yesterday. Not all radiation is bad. And what's interesting is we actually use beta radiation with making of aluminum foil. So I thought that was pretty interesting, and you'll see that in your summary. Do not forget to submit that Google Doc talking about the different types of particles and what should be used in that situation that I gave you, okay? Once again, alpha releases a helium, beta, a neutron, becomes a proton and electron, and it spits out an electron. They're both changing from one type of atom to another. This can only travel a few inches. This one can travel a few feet. All right. Alrighty. Now, I'm going to kind of move on over here to gamma. Now, gamma is obviously what we're talking about with the Hulk. It's a little bit more exciting. And you're like, ooh, it's a lot different. Yeah, it is a lot different. Here's why. Gamma is not a particle. Gamma is pure energy. And it travels in waves. Specifically, electromagnetic waves. You guys should have heard this in our circus unit when we went to the circus. We talked about the different types of energy and we focused on light energy. And that word electromagnetic popped up. Electromagnetic waves. Okay? Now, the electromagnetic waves cover an entire spectrum. So to kind of show you what I'm talking about here, I will type this in, electromagnetic spectrum. And I mean, you can do this yourself. I'm literally Googling this in front of you. But you can kind of see, I'll try to make it a little bit bigger here for you. Oh, here we go. So I'm going to copy the image. I'm going to bring it over here into my slides so I can blow it up a little bit for you. But here you go. So, I mean, you can see this in all different types. But and we'll actually get further into the electromagnetic spectrum. Right now, I just want you to understand that gamma is a type of radiation, okay? So you can kind of see there's different wavelengths, okay? There's different parts of the electromagnetic spectrum. What we focus on, you see that nuclear symbol there, you see that Hulk symbol, that's what we're looking at down here, this ionizing radiation, okay? In other words, it can damage and hurt your cells, okay? Other types of radiation that you use, you notice that X-rays are down here. And that's right. X-rays fall in this part of the spectrum. That's what's really important when you go get an X-ray, that the parts that you don't want X-rayed, you cover with lead, okay? You know why? Because, if I come back over here, gamma rays, as well as X-rays, can be stopped with lead. Now, they're extremely powerful, okay? But they can travel thousands and thousands of feet, okay? So they can travel thousands of feet. Actually, let's kind of reword that. Let's put that as hundreds of feet. I think that'd be a better way of saying it, okay? They also can be stopped by concrete. That's something else to kind of think about as well. But they can be stopped. So when we think of gamma radiation, we always think of the Hulk. But this also includes things like X-rays. And there's other forms of electromagnetic waves that are ionizing, okay? But gamma radiation is, okay? Now, this one to me is probably the simplest to understand. It's also important because this is a wave. This is pure energy. This is not a particle. There is no mass, okay? And there's no charge to this. So we're over here. We had all these like, oh, it's releasing this negative. It's doing this. Not in this case, okay? So I'm going to move things up a little bit so that you guys can kind of see gamma. So big thing here, think Hulk with gamma rays. And that's why I kind of showed that at the beginning. All right. Last but not least, neutron radiation. Now, neutron radiation was not in your notes. And by the way, if you would like to kind of see some information about gamma, you can come over here. You notice that for gamma rays, we use the symbol of Y, which is gamma in the Greek alphabet. So make sure you know those Greek symbols. It's really important. Okay? And you can see little fun facts about nuclear explosions, little history of nuclear fallout shelters. The one thing you'll notice is the notes are cut off. I did that on purpose. The reason I did that was because you guys aren't ready for this yet. This is about half-lives, and I don't want to overwhelm you with that. So I kind of cut it off. Don't want you focusing on that. Okay? The last thing I want to go over with you guys is neutron radiation. Okay? Actually, this is a very, very rare form of radiation. However, it is extremely fast, and it's the fastest. It is actually can travel the longest distances compared to the others. We know that gamma can travel very far, but it's not cannot travel as far as neutron. Now, this is extremely powerful, okay? And it is thought to be able to turn other things radioactive, okay? So sometimes we call it's indirectly ionizing when it comes in contact with other things, okay? It has a very, 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 very short time span. So in other words, it does not stay powerful for very long, okay? But if exposed, it is extremely dangerous. Most of the time, neutron radiation can be stopped with water or concrete. Most of the time, your nuclear reactors have this in there. And we're going to actually talk about how a nuclear reactor works. That's coming up. But you normally find neutron radiation at the core of a nuclear reactor, where nuclear fission takes place. Okay? And we're going to actually get into a lot of detail with this. But these are the more common ones that you're going to see and talk about. With all of these guys, you need to know that the reason they emit radiation is because they are unstable. That atom is unstable. And that goes into your Hulk smash question. So I'm going to just hit save and close here. It's probably going to change things up a little bit. So explain why the nucleus may or may not emit radiation. If it's stable, it's not going to. Okay? It does not, it will only emit radiation if it has an unstable ratio of protons and neutrons. It has to be unstable. Okay? The last thing I do want to kind of make sure that I include for you here is the understanding the word of the least penetrating to the most. In other words, what we're saying it is how far it will actually go. And we know alpha particles, beta particles, gamma rays, remember those are waves, and then neutron. And I'll kind of pull that up so you guys can see it. So if you want to include that, that's also going to be on the notes that I'm going to post as well for you guys to check your tip chart and so forth. For your sorts, I will post the answer to this. I know it kind of be hard on dark paper, but I'm just going to use the key like neutron, beta, gamma, neutron for you to check your work. I'm open for questions, anything you need. I am going to be posting some extra kind of support videos to help you just in case this doesn't make any sense. Remember, feel free to ask me questions. Another thing you can do, and I meant to show you this picture earlier that may help, is the degrees of penetration. We were just talking about how far it will actually go. So you can kind of see, and I don't like the words use rays here. This should be particles. This is what happens when you just grab a picture really quick. But alpha particles, you can see beta will go through, goes to aluminum. Gamma radiation, X-rays, they go all the way through but can be stopped by lead, where neutron radiation can go all the way through and can be stopped by water or concrete. Okay? Please let me know if you have any questions, guys. I'm here to help. Check out all the resources that I'm giving you. I hope you have a wonderful day. And this will be the last video of the week. I will see you guys, or actually post something for you and talk to you on Monday. Have a good one.